Hey, how's it going, everyone? So today we're going to be walking through how to properly handle null values in Python. If you're a data analyst, scientist, engineer, BI developer, you're going to be handling nulls pretty much all the time. Any real-world dataset has nulls, and you need to understand how to handle them correctly for your situation. We're going to be working with a dataset from Kaggle, which I will leave a link to in the description of this video so you could follow along, as well as the GitHub repo where you can download it as well. And this dataset has yearly data about movies from 1960 through 2024. And we're just going to be looking at one single year. And for this example, we're going to be using 2024. Before we dive into the various methods, probably the most important thing to know before handling null values is you really need to understand what you're doing with the data. Are you doing analysis? Are you preparing the data for other stakeholders in your company to use? Are you preparing the data to train a machine learning model? And if so, what type of model are you going to be using? The answer to that question is going to dictate how you're going to handle your null values. So first, let's just take a quick look at our data. I'm going to import Pandas as PD. I'm going to read the data frame, which I have here in the working directory, merged movies data. And we can see here that we have 600 rows and 23 columns. And if we took a look at the data, we could see that we have the title of the movie, we have a link to the movie, the year, the duration, the rating, the audience rating, number of votes, the budget, the gross worldwide revenue, the gross US-Canada revenue, etc. We have additional columns over here. And if we do df.info, we could see each of our columns and how many non-null values each one has and the data type. And we could see for many of them, there are 600 non-null values, which means that the data is fully populated for that field, because we saw before that we have 600 rows in the data. So there are 600 non-null, means that they all have a value. However, for many of them, there are null values because there are less than 600 non-null values. So moving on to how we're actually going to handle the null values, the first thing that I actually wanted to mention is that sometimes you don't need to do anything to your null values. We could actually just leave them there because many machine learning models actually handle nulls naturally, like tree-based models. Other models, such as linear models, such as linear and logistic regression, do not, which means that you will have to handle the null values. Also, if you're preparing data to be used company-wide, sometimes the null values can be important because they could actually have a meaning to themselves. For example, let's say you have a credit card application form, and one of the features is the applicant's credit score. It could contain a number, or it could be null because the applicant has no credit history, and we wouldn't want to drop or do anything with that null value because it actually does contain important information. So if we do want to handle the null values, the first and simplest way to get rid of them is just to drop all the fields that have null values. So looking over here, we could see that we have 600 rows and 23 columns. And using the df.dropNA, we could drop every row that contains a null value. And after all is said and done, we have only 98 rows left. So we've dropped over 500 rows, which is not what we would like to be doing in all likelihood. The next simplest thing that we could do is actually to drop the columns which have a high percentage of null values. So over here, we're going to look at how many nulls are in each column. So if we look at df.isNA.sum, we could see the number of null values in each of these columns. So we can see over here, duration has 6 null values, MPA has 231 null values, budget 449. And now we can take the number of nulls in each of these columns and divide it by the total number of values in each of these columns. And then that will give us a percentage of nulls in each column. So we're going to take the null values.sum and divide it by the null values.count. And this will give us the percentage that we're looking for. And MPA is 38.5% null. Rating is 0.5% null. Budget is 74.8% null, etc. So now let's say we wanted to take some sort of threshold and say that we don't want any columns that have more than 50% null values. We could simply take this line of code that I have over here and set it to less than 0.5, and we could see what is true and what is false. If it's false, then that means that it has more than 0.5 or 50% null values. So in total, we have the budget and we have the opening weekend gross, which have more than 50% null values. And if we go over here, we could see that budget is 74.8% null, and opening week gross is 50.33% null. So this is working correctly. We could see that these are the two columns that we would like to drop because they contain too many null values. And what we're going to do here is we're going to take the values from this equation, and we're going to take only the values, the true false values, to create a Boolean mask, which we're going to use to keep only the columns which have less than 50% null values. So here we're taking the values, and we can see we have an array of true and false values. The false values over here means that there are too many null values. It's above our threshold. And I'm going to set this equation to a variable called col non-nulls, meaning the non-null columns. And then we're simply going to do df.lock, take all of the rows, and take only the columns which are non-null, meaning that they are below our threshold of 50% null values. And then if we take a look at our new data frame, previously we had 600 rows and 23 columns, and now we have 600 rows and 21 columns. So we can see that it has worked correctly. It has dropped the two columns that we did not want to keep. However, let's say we don't want to drop the columns that contain null values. We don't want to drop the rows that contain null values. We want to keep all of the information in our data set because we don't want to lose that information. So there are other methods that we could do in order to guess what we think the null value would contain, essentially our best guess of what we think it could be. And there are various different methods of doing this. And the first one that we're going to do is we're going to fill the NA values with the average or the median values of that column. And in order to do that, we're going to take a look at an example here. We're going to look at the gross worldwide column, and we're going to look at the tail, which just means the bottom 5 rows. And we could see here that there are a few null values. And we're going to try to take the average and the median of this column and impute these values with the average or the median. And we're going to see what that is going to give us. So we could see that over here, the mean value, that is the average, is 41,938,000. And the median value is significantly lower, 1.726 million. And we're going to try to take these values and impute the null values with these values. And in order to do that, we're going to save each of these as a variable. The average gross worldwide is this value right here, and the median gross worldwide is this value right over here. And now we're going to take the column and do fill NA and use the median gross worldwide value and take a look at it once again. And we could see over here, previously we had null values for 597 and 598. And now in 597, we have it filled with the median value, which we saw before, is 1.726 million. This number right over here. And we could do the same exact thing for categorical or string columns. Let's take, for example, MPA, which we could see here is the rating, and we see there are some null values over here. We could simply take these null values, and let's say we don't want to see null over here. We'd rather see something else like not rated, because a null value in the rating means that it just doesn't have a rating. So we'd like to see not rated, because having the null values here could give us some issues with some functions in Pandas, etc. So we're going to do df MPA, and we're going to fill NA with not rated. And now we can see that the null values are all filled with not rated. And this seems like it should be a pretty good method. However, it does come with some drawbacks. If you fill every null value with the same value, it could mess up certain statistics or analytics, and it's just something that you need to be aware of. So let's say, for example, we take the gross worldwide. If we look at the histogram over here, we could see that there are a very small number of movies with a tiny gross worldwide revenue. And as the gross worldwide revenue gets larger, then there are less and less movies with that amount of revenue. However, if we would impute the value with, let's say, the average gross worldwide revenue, it would make it look a bit different. Here's what the histogram looks like if you fill NA with the average gross worldwide value. We can see that the histogram looks a little bit similar, but we have this interesting spike right here. And this means that there are a lot of movies that have this exact amount of gross worldwide revenue. And before we had a nice curve of a lot of movies for very small values, getting less and less for the larger values. And now we have this spike in the middle, which looks very suspicious. So it's something that you need to be aware of if you're doing analysis on this data. Now, moving on to our final and most sophisticated method, we can also impute the values, not based on the average, not based on the median, but based on some sort of algorithm that will give us the best guess of what we think these values may actually be. And for this example, we're going to be using the k-nearest neighbors algorithm. There are other algorithms that you could use, such as regression, but we're going to be using the k-nearest neighbors for this example. So first, in case you don't have scikit-learn installed, you're going to pip install scikit-learn. In my case, I do have it installed. And now from scikit-learn.impute, we're going to import knn-imputer. And just to remind ourselves of the columns that we have, I'm going to do df.info so we can see the number of nulls in each column. And we're going to choose for this example 3 sample columns that we're going to impute. And I'm going to take the budget, the gross worldwide revenue, and the gross US-Canada revenue. And here you can see that's these 3 columns over here. And we can see that each of them have less than 600 non-null values, i.e. they do indeed have null values. And we're going to try to impute the null values based on the k-nearest neighbors algorithm. And we're going to save this list of these 3 columns as a variable called columns to impute. And if we take a look at these columns in the data frame, we can see that on the bottom here, there are indeed a lot of null values. And we're going to try to guess what we think these values could be based on the KNN algorithm. So we're going to save an imputer object based on the KNN imputer with nearest neighbors equaling 2. This will choose the 2 nearest neighbors for each one of the missing values. And in order to run the imputer, all you have to do is do imputer.fitTransform and then take our columns to impute. And then it will try to fill in the null values based on the algorithm's best guess. So let's run it right here to see what it comes up with. And now it will give us an array of the values. And if we want to see this array as a data frame, we could just put it inside of a data frame. And we're going to keep the column names the same as we had before. And let's run this and see what it looks like. And now you can see the updated values. And there are no more null values here. They have been filled with the best guess based on the nearest neighbors algorithm. Now, finally, before we conclude, like I mentioned in the beginning, the method that you use really will depend on your use case. So it's really important to have an understanding of your data and what you're using it for. And to give a few broad rules of thumb to give you some direction, if you're doing analysis, then you often will need to fill the values via imputation or average because many functions and packages are not able to handle nulls well, so you will have to do something with them in those cases. Other functions do have some sort of default null handling method, oftentimes ignoring them entirely, which will impact your analysis. For example, many Pandas functions such as value count or group by default ignore nulls unless you explicitly tell them not to, which is just important to know if you're going to be using those functions. And if you're preparing data for other stakeholders, most of the time you should leave the nulls there so that they could see the unmanipulated versions of the data. Finally, if you're training a machine learning model, you really need to check if the model can handle nulls and also whether your features contain too many null values, which are creating more noise than giving you information. And in that case, you might just want to drop them. That's all for today's video. Don't forget to like and subscribe if you enjoyed, and have a great rest of your day.